Hi friends, today we'll be discussing March 2021 Chief Mate Phase 1 MMT question answer. A vessel of length 141 meter, CO of 2.6 meter, forward of midship, MCTC 144, TPC 19, KM 7.7, KG 6.9, W 11,300 tons, is floating at a draft of forward 3.8, aft 5.68 in a dry dock where the depth of water is 6.5 meter above the top of the blocks. Calculate the vessel's residual GM and draft forward and aft when water level is lowered by 1.75 meters and the vessel is unstable. So the LCF will be coming L by 2 plus the CO of 2.6 meter forward of midship. So it will be 73.1 meter and trim from the forward and aft we will get 1.88. Correction to correction to aft draft, that will be trim into LCF divided by LBP. It will be coming 0.975. So the hydrostatic draft will be 5.68 minus 0.975. It will be coming 4.705. Stern will test the blocks after the drop in water level. That means when when the vessel just entered the dry dock, it was 6.5 meter the depth. But when the stern touches, the water level will be 5.68 because that's the vessel's updraft. So 6.5 minus 5.68, that will be the drop in water level when the stern touches the block. So it will be 0.82 meters. Drop in water level after stern touches the block. In the question, they have given that water level is lowered by 1.75 meters. So we need to find out how much more the water level has taken place. Drop in water level after the stern touches means 1.75 minus 0.82 meters. It will be coming 93 centimeter. Now we need to find out how much will be the drop in water level till the critical instant after the stern touches the block. We know the trim change that will be equal to the initial trim, that's equal to 1.88, that's equal to 188 centimeter, that's P into LCF divided by MCTC. So the P will be coming 370.342. So the reduction in hydrostatic draft will be 370.342 P by TPC. TPC we know 19 meters. So it will be coming 19.492 centimeters. So in meters 0.195 meters. So the new hydrostatic draft will be 4.705. That's the initial hydrostatic draft minus the reduction in hydrostatic draft. Also we can call rise 0.195. It will be coming 4.51 meter. That is a new aft draft because it has taken all along the length the blocks. So the hydrostatic draft will be equal to the forward draft equal to the aft draft. So the drop in water level till the critical instant will be 5.68 initial aft draft minus new aft draft, that will be 4.51, that is 1.17. So the drop in water level of 93 centimeter will occur before the critical instant. This we have already calculated how much water has dropped below after the stern touches the block. It is given as 93 centimeter, but when the drop in water level reaches the 1.17 meter, then only the vessel will take all along the blocks. That means the 93 centimeter will occur before the critical instant. So the 93 is equal to P by TPC plus P into LCF square divided by MCTC into LBP. Once we equate this thing, we will get the P value. P value will be 294.479. So the final displacement will be 11,005.521 tons. The reduction in hydrostatic draft will be P by TPC. P we know 294.479 divided by TPC 19. It will be coming 0.155 meters. So the final hydrostatic draft will be initial 4.705, which we got already, minus 0.155 meters. That will be 4.55 meters. Now we need to find out the trim change because we know now the ship is not fully resting on the blocks. Now we need to find out how much the trim change has occurred. From there we can find out what's the final trim at that instant. Trim change is, we know, P into LCF divided by MCTC. P we got, and LCF also we have, MCTC also we have. From there we can find out the trim change, that is 1.495. The initial trim was 1.88 and the trim change is 1.495. So the final trim will be 0.385. So the correction to hydrostatic draft will be 0. That is trim into LCF divided by LPP. That is trim is 0.385 into 73.1 divided by MCTC, sorry, divided by LBP, that is 141. LBP, that is length 141. We got correction to hydrostatic draft is 0.2. So the final updraft will be 4.55 plus 0.2, that is 4.75, and the updraft will be 4.75 minus the trim 0.385. That will be the final forward draft. Now we need to find out the final GM. Loss of GM we know P into kg divided by final W, that is 294.479 into 6.9 divided by 11,005.521, that's equal to 0.185. The final GM will be 7.7 minus 6.9 minus 0.185, because Km minus Kg minus loss of GM, they haven't given any FSC, otherwise they would also, FSC will also will take part in the final GM. So it will be coming 0.615 meters. The second question was, when the vessel becomes unstable, that means the GM will be 0. The final GM will be 0. Initial GM we know 7.7 minus 6.9 K minus Kg, that is 0.8. That should have been equal to the loss of GM. Then only the vessel will become unstable. That's the instant when the final GM is equal to 0. So the initial GM should be equal to the loss of GM. So P into Kg divided by W minus P. We know the initial GM 0.8 equate to that thing. That is so the final answer will be P is equal to 1174.026. Here we know P into kg. Sorry, P we don't know. We will put P into kg we know. Divided by W we know. P we don't know. But we know the zero. Here the initial GM is 0.8. Once we equate that thing, we will get P is equal to 1174.026. So the reduction in hydrostatic draft will be P by TPC 1174.026 divided by P, that's equal to 61.791 centimeter, that's equal to 0.618 meters. The final hydrostatic draft will be equal to 4.705 minus 0.618. That's a correction. So that's equal to final forward and aft draft. Draft is equal to final forward draft, that's equal to final aft draft, because the p value which we got right now, that is 1174, that's the virtual loss of displacement. But in the initial stage we have calculated how much will be the p value once it once the vessel has taken all along the blocks, that is 370. So the once vessel takes the blocks all along the line, the p value was 370 only, but the calculation it is 1174. That means this GM fluid has occurred after the vessel takes all along the blocks, or